Mercury. It is of course the solar system's closest planet to the Sun. Stick with me on this video and you'll learn everything you need to know about Mercury. Everything I'll show you today will be actual picture or video images of Mercury. We'll be talking about the orbit and rotation of Mercury, its physical characteristics, its surface conditions, and the magnetic field and magnetosphere of the planet. Now when you think about the physical characteristics of Mercury, I'm sure you imagine it being the closest planet to the Sun and this giant rock just floating in space. You wouldn't be too far wrong with that, but it is much more interesting than what you may first think. For example, when I look at Mercury, I do think of our moon, but Mercury actually is visually more appealing than our moon. Look at it in its true colour. The first thing that I notice is that it actually does have a colour. It's not just different shades of grey. And what else? Well, did you know, for example, that Mercury consists of approximately 70% metallic and 30% silicate materials? Because of this, Mercury's density is the second highest in the solar system at 5.427 grams per centimeter cubed, only slightly less than the planet with the greatest density, that of Earth, at 5.515 grams per centimeter cubed. If Mercury happened to be the same size as Earth, that would mean it would have pretty much the same gravitational pull as its surface. But being the size that it is, its surface gravity is only 3.7 meters per second squared. If you would compare it to Earth, it would look something like this. This means the surface gravity of Mercury is only slightly less than what it is on Mars. And considering Mars is a much bigger planet, that just says something about the density of Mercury. Before we leave the subject of Mercury and its size, I want to show you one last comparison, that of Ganymede and Titan against Mercury. Now Ganymede is the solar system's biggest moon and also the biggest moon of Jupiter, while Titan is Saturn's biggest moon and is the second biggest moon in the solar system. These two giant moons are bigger than Mercury, as you can see here, but their masses are less. If you look closely at Mercury's surface, you'll see its appearance is similar to that of the moon. It shows extensive Mare-like plains and heavy cratering, indicating that it has been geologically inactive for billions of years. But it obviously was geologically active at one point, because one of the distinctive features of Mercury's surface is the presence of many narrow ridges, extending up to several hundred kilometers in length. It is believed that these were formed as Mercury's core and mantle cooled and contracted over time when the crust had already solidified. And one distinctive thing you'll notice about Mercury is this huge crater on its surface, Caloris Basin, with a diameter of 1,550 kilometers. The impact that created Caloris Basin was so powerful, it caused lava eruptions and left a concentric ring over 2 kilometers tall surrounding the impact crater. At the antipode of the Caloris Basin is a large region of unusual hilly terrain known as the Weird Terrain. If you would compare it to the rest of Mercury, you would see why it would have this name. So, what's it like on the surface of Mercury? Well, to start with, the surface temperature is hugely different all over. It can range from minus 173 degrees centigrade to over 400 degrees centigrade. It never rises above minus 93 degrees at the pole because there's no atmosphere retaining the heat, and so there's quite a big difference between the equator and the poles. But it's also due to its orbit and rotation, which we'll get back to later. The subsolar point reaches about 400 degrees. While on the dark side of the planet the temperatures average minus 163 degrees. Because Mercury is too small and hot for its gravity to retain any significant atmosphere over long periods of time, it's not able to retain any of the heat it gets from being so close to the Sun, which is why the dark side of the planet is so much colder than the side facing the Sun. Mercury though does have an exosphere, which is like a very thin atmosphere-like volume surrounding the planet where molecules are gravitationally bound to that planet. But the density is so low that it can't behave as a gas because these molecules don't collide with each other. In this picture you can see proof of the exosphere. When solar winds hit the planet, they rip off certain atoms out of the exosphere, and what's left is this trail of atoms going into space. We call this the planet's tail, and every planet has this to a certain extent. Earth does have an exosphere, but it's 600 kilometers above the surface. It's really the point where space and the atmosphere meet. Now in the case of Mercury, this exosphere is not at all stable. Atoms are continuously lost and replenished from a variety of sources. Very recently, NASA's been able to confirm that craters at the North Pole contain water ice. Mercury also has something which Mars lacks, an actual magnetosphere or a magnetic field all around the planet. Now it is only about 1.1% as strong as Earth's, but it's still strong enough to deflect a lot of the solar wind around the planet. And now finally we're going to get to one of the things which I find the most interesting about Mercury, its orbit and its rotation. Mercury has the most eccentric orbits of all the planets, with its distance from the Sun ranging from 46 million kilometers to 70 million kilometers. Now this is something a bit hard to imagine. Mercury takes about 88 Earth days to complete an orbit around the Sun. It also has a 3-2 spin-orbit resonance of the planet's rotation around its axis. This means it spins 3 times around its axis for every 2 times that it orbits around the Sun. So although it takes about 59 Earth days for Mercury to rotate on its axis, but with this 3-2 orbital resonance, actually standing on Mercury, it would appear that one day from sunrise to sunrise is 2 Mercurian years. Standing on Mercury, that would look something like this. You see the Sun rise quite fast, and then as it approaches midday, it slows down and even starts going backwards before continuing on again to sunset. As you can see, that took a whole year, which means a nighttime on Mercury also takes a year. The Sun starts going backwards in the sky because approximately 4 Earth days before perihelion, the speed in which Mercury rotates around its orbit equals the speed in which it's rotating, so that the Sun's apparent motion stays stationary. At perihelion itself, Mercury's orbital speed exceeds its rotational speed, so to a person actually standing on Mercury, the Sun appears to move backwards. 4 days after perihelion, the Sun's normal motion resumes. You can see this even clearer from a top-down perspective of Mercury on one of its poles. Twice a day, the Sun seems to pause and then continue on again. Something else to note about Mercury's orbit is it's inclined by 7 degrees to the plane of Earth's orbit. As a result of this, we can only see Mercury in front of the Sun when it's directly between us on Earth and the Sun itself. And because its orbit is inclined by 7 degrees, this only happens about once every 7 years. And finally, about the rotation of Mercury, its axial tilt is almost 0, with the best measured value as low as 0.027 degrees. This is even smaller than that of Jupiter, which has been measured at 3.1 degrees. And finally, do you want to see Earth from Mercury? Well, here we are, just a couple of pixels across. This picture was taken from the Messenger probe a couple of years ago, and every single one of us was in this picture.